So we're looking at this problem. It's comes from 4B. It's called the power of compounding, and it asks us to use the appropriate compound interest formula to compute the balance in the account after the stated period of time. 23,000 is invested for 2 years with an APR of 3% and daily compounding. So let's take a look at our formula sheet. And the formula sheet is right here. And I'm going to scroll down until I get to the chapter 4 formulas, which we have them right here. There are 4 of them. The first one is simple interest. The interest is equal to principal times the rate times the time. The second one is compound interest. This one is this compound interest one that is listed here. And the simple interest one are the ones that you're going to see in 4B. And the savings plan one, now this also involves compound interest. This is used in 4C. The difference between the two of these is that the compound interest is in a lump sum. So if you make a large deposit all at once at the beginning, that's when we use this compound interest formula. And if you are making a regular deposit, so say, for example, you are saving $100 a month for the next 10 years to build up a savings, to maybe purchase something 10 years from now, that is when you use the savings plan fund. So that is this does involve compound interest, but just a regular monthly deposit, where this one's a lump sum. And the last one you see here, this is in use in 4D. This is loans. So whenever you see anything about mortgages, student loans, credit cards, this is the formula that they are asking you to use. So in this problem, it is an initial investment of 23,000 all at once. So it's this formula that I'm using. So I'm going to copy that over to my whiteboard. So in this formula, I see a lot of different variables. We've got A. A stands for the future amount. How much are you going to have after so many years? P stands for the initial amount. What are you initially investing or saving? So initial amount, also known as the principal, so that's why they call it P. The APR, this is the annual percentage rate. So this is the interest rate. And that interest rate, to use it in this formula, you have to have it in a decimal form. So you're going to remove the percent sign and you're going to move the decimal point 2 places to the left. Then I have N, and I have N twice. N is the number of compounding periods. So how many times per year is it compounded? And so the common ones that we see are annually. And if it's annually, then my N is 1. So if you see the phrase annually, if you see the phrase semi-annually, that's twice a year. Another common one is monthly. Oh, here, let me do quarterly next. That's a common one, quarterly. Quarterly would be 4 times a year. There's 4 quarters in a year. Monthly, there are 12 months in a year, so 12. Daily. For daily, our book average 365 days a year. And we could see even more than this, but these are the most common ones. So that's our N. And then the last thing I see here is Y, and Y is the time, and that's in years. So you want to make sure the units here are years. So let's use this formula now to complete the problem. And so what I like to do is I like to write the variables off to the side down below. And then I'll go pick them out of the problem. Because sometimes we'll have to read through a whole paragraph to decipher what those variables are. Let's go back to the problem. This one is just this one sentence. 23,000 is invested. So that is the amount that's initially invested. So that's going to be my principal. And then it said, for 2 years with an APR of 3% and daily compounding. So 2 years is the time. And it tells us the APR is 3%. But I need to change that to a decimal, so I drop the percent sign and I move the decimal 2 places to the left to make it 0.03. And because it says daily, that's 365. I am looking for the future amount, so that's my unknown. So what I'm going to do is I'm going to go in the problem in my formula and I'm going to fill in the things that I've just learned. So 23,000 will go in place as P. I'm going to erase this APR and I'm going to put in 0.03. The N, I'm going to erase that and I'm going to put in 2. And then the Y, I'm going to erase that and I'm going to put in 2. And actually, I made a mistake here. I'm sorry. I was looking at the wrong thing. The N is 365. So 365 is N. Now, I got to keep this exponent together. It's 365 times 2. So either do that multiplication or make sure you surround the exponent with parentheses on your calculator. So let's pull up the calculator. And what I would encourage you to do is to do this all in one step. Because we have access to the graphing calculator. And remember that you can borrow one. The Learning Commons has them to loan out. The library, some local libraries will loan them out. So the TI 8384 is what you want to have in the math class to do these problems. And it's going to come in handy using it here. So I'm going to go to my calculator. Here's my calculator. And I'm going to put in, and let's see if I can expand my screen so that I can have both at the same time. Hold on. So I'm going to put this formula that's here, I'm going to put it on my calculator and I can be able to see everything. But if you were doing this in pieces, then you have to keep in mind the order of operations. So you want to do what's in the parentheses first, then you want to raise it to the exponent, then you would multiply it by the 23,000. The order of operations goes parentheses, exponents, multiplication and division left to right, and addition, subtraction from left to right. So what you would be doing is you would do this division, you'd work inside this parenthesis, doing this division first, adding 1, then taking whatever this number is and raising it to the end result of the multiplication here. After you get that complete thing, then you multiply it by the 23,000. So quite a few steps if you're doing it in pieces. So make sure that if you're doing it in pieces that you follow this. But what I'm going to show you here is how to enter it into the calculator all in one step. And then with this large screen, you can look and see how you've entered it and if you've made any mistakes. Because one little minor error will change the answer. So 0.03 divided by 365 and close the parentheses. So this is what I have so far that matches what is here. Then I'm going to say, now I have to hit exponent. So that's the exponent above the division sign. And this calculator that I have on the screen makes a superscript, but not all of them do that. Some of the TI-83s will just have a caret symbol and then followed by the exponent. And you have to surround that with parentheses to tell the calculator that this whole thing is the exponent. Now, that's on the TI-83. If your superscripts it like this, you don't have to because everything in the superscript is the exponent. So, but I'll put it in here usually just because some students use the TI-83, some students use the TI-84. Different models do different things. So now when I hit enter, this is the answer I get. This is the future amount after 2 years with daily compounding. This is how much will be in the bank. 24,422 and 18 cents. I'm going to round everything. Typically, unless asked otherwise, I'm going to round to the nearest hundredth. That's the nearest cent. So let's go to, I'm going to write that on my screen. So the answer I get is 24,422.18035. But like I just said, we want to round to the nearest cent. And so I'm going to look 1 to the right, and since that is less than 5, I'm going to keep the 8. If it was 5 or more, I'd round this number up to 9. So this is the answer I get, and I'm going to put it in the MyLab Math and make sure that my answer is correct. And so, and it tells you usually in parentheses round to what place to round to. So now I'm going to hit check the answer, and it gives me the green check mark. And so then I know I've done it right, and I can move on to the next.